Okay, so shifting gears now, we're going to look at present value of a dollar and present value of an annuity. So as important as it is for us to understand the future value of money, it's also important that we understand the present value of future cash flow. It's not uncommon for sport managers to sign contracts that involve future cash flow. So it makes sense that we'd be asking how valuable in today's dollars a future dollar amount might be. Because now we know that things like inflation and other factors could have an impact on the value of money over time. So we want to take those things into account when we're trying to determine the present value of future cash flow. So one way that we do this is by determining a discount rate. So as you can see here, a discount rate is a measure of risk or uncertainty applied to present value calculations. So discount rate might be determined by a number of variables. You might take into account future inflation rates when you're putting together a discount rate. You might think about interest rates. You might look at the overall economic environment, or you might assess specific risks associated with a potential partner that you're getting into a contract with. There are a number of factors that might help you determine an appropriate discount rate, but ultimately it's a way for us to assign risk so that when we do calculate the present value of future cash flow, we're doing so conservatively, and we're not planning for money that may or may not be there down the road. So before we look at the formula for present value of a dollar, I do just want to mention that as we think about discount rates and how sport organizations can use them, it is important that, in the real world, the sport organization would want to consider more than just one discount rate when they're calculating present value. When we think about it, sport organizations cannot always predict the future, right? So if they consider multiple outcomes, then they have a more comprehensive view of what could happen. Again, at the end of the day, financial managers are basically making estimates based on the information that they have. So they may not always be able to predict the future. That's why it becomes important to consider multiple discount rates. Now, I likely won't ask you to consider multiple discount rates in different practice questions or on test questions just because it's time consuming. But just know that in all likelihood, if you were given a scenario to assess risk and assign a discount rate, you would probably want to consider a number of discount rates in those assessments. Okay, so our first formula here is going to be present value of a dollar. You can see our formula is here. PV is present value is equal to future value, and then we have our parentheses here with our multiplier to get to our multiplier. In order to do that, we need a few pieces of information. We need the discount rate per period, and then we need the number of periods. Okay, so basically the number of years the payments are going to be made. Okay, so let's look at an example. So here we have a minor league baseball team that has a commitment from a sponsor for a $20,000 payment in 3 years. So they've scheduled this payment 3 years down the road. So it's a one-time payment. We want to calculate what is the present value of that money if it is discounted at 4%. So essentially the team has determined that there is some risk associated with getting into this sponsorship arrangement. It's a mild risk, though 4% is not a terribly high discount rate. But they want to account for some risk. So again, here's our formula to calculate the present value of that payment that, again, is not expected for another 3 years. But if we're making plans financially, we want to be able to predict what that value might be. So here is our formula applied. Right, so our present value is equal to future value, which we know is $20,000. That's the future value of the payment. And then we want to multiply that times our multiplier, which we get by plugging in both our discount rate of 4% and the number of periods, which in this case is 3 years. Okay, so again, we'd run through that in the calculator. That would give us this multiplier of 0.8890, which we would multiply times 20,000. That gives us a present value of $17,780, okay? So again, the nominal value of this contract, right, if we just look at it at face value, is $20,000. But again, the minor league team has determined that they want to assess a risk at 4% discount rate, right? So they're taking into account likely inflation that occurs over that time. There may be other risks that they're wanting to consider in terms of the economy. Ultimately, if they're making plans today on how they might use this money, they want to be a little bit more conservative and consider it to be worth about $17,780 and not $20,000. Okay. All right. So we can use the formula that we have to calculate present value of a dollar, or once again, we can use our handy dandy appendix in the back. So in order to do present value of a dollar, we use appendix A3. Okay. So if you go to appendix A3 in the back of your textbook, if we apply it to this scenario, we know it was 3 years in which that payment was going to be made, and it was at a 4% discount rate. So if we look here, we see that gives us a multiplier of 0.8890. What do you know? That's exactly the multiplier we got when we did this the long form. So again, this is just another way for you to get to that multiplier. Again, if you were to use the table instead of the formula, you would just plug that number in and multiply it times the future value of 20,000, which would give you the exact same result. Okay. So the last formula we're going to look at here is present value of an annuity. So we just looked at calculating present value of a single payment, but once again, we want to be able to calculate the present value of a series of payments as well, and that's where the annuity comes in. So here you can see we have a new formula, right? We have PVA, which again is present value of an annuity, is equal to our payment times our multiplier, which in this case is quite a process to get to, but the key pieces of information we need are the discount rate and the number of periods. So same information really that we needed in order to assess present value of a dollar. So let's look at another example here. So a sports agent has just signed a 5-year sponsorship deal for his client. This long-term sponsorship deal will result in yearly payments, so that's important to know, of $10,000 for 5 years of time, right? So the agent has determined that a discount rate of 10% is appropriate. Pretty high discount rate, right? So clearly the sports agent is concerned about whether or not this sponsorship deal will be fulfilled, because they're putting in a pretty high discount rate here to calculate present value. Okay, again, we have our handy dandy formula here to calculate present value of an annuity. So if we go ahead and plug our numbers in, again, we know that in this case, the payment each year is going to be $10,000 that the player receives. To get to our multiplier, we have to plug in both the discount rate, which in this case was 10%, and the number of periods. We know it's 5 years, so we plugged in our 5. So if we run through this on our calculator, we get a multiplier of 3.7908. We multiply that times our payment, which we know in this case is $10,000. That gives us a present value of annuity of $37,908. Okay, so remember, this particular contract is a 5-year contract, $10,000 a year. So nominal value of that contract is $50,000, right? But based on this agent's discount rate of 10%, the present value of that annuity is much lower, right? $37,908. And we don't know the specific reasons for having him give it or designate it such a high discount rate, but we know that there are some risks at stake here in terms of whether or not this money is actually going to end up with the player. So because of that, they've been pretty conservative with the discount rate, and in terms of financial planning, that player may want to be a little bit more careful in terms of the investments they're making and the spending they're planning over this 5-year time, because based on our assessment of present value of this annuity, it's going to be much lower than the actual nominal value. Okay, again, we can use our handy formula there, or we can use our last appendix for time value money, which is A4. So A4 in the back of your book gives us present value of an annuity, right? So in this case, we know the agent was assigning a 10% discount rate, so we go all the way down here to 10%. We know it was a 5-year period, so we find our cross number here, and we find a multiplier of 3.7908. Once again, looks familiar, right? This is the exact same multiplier we had found when we did it long form. We multiply that times our 10,000, we get the exact same answer, which is 37,908. Okay. So that is it for the content I have for you on time value of money. Now I know we covered a lot of ground this week in terms of the various approaches to looking at the changing value of money over time. Obviously, we've identified a bunch of new formulas today, and we've also incorporated the appendices as a way to help find the multipliers for these formulas. So I know it's a lot of information. That's why I've given you some additional practice cases under your action items for this week. And again, this is a way for you to get some more practice when we come together again in class next week. We'll make sure to go over the answers together, and we'll also probably look at some additional practice cases in our breakout rooms. But as you are approaching these practice cases in your module this week, I want you to consider two different questions as you assess these, because I know one of the biggest issues students have with the time value of money questions is they're not sure which formula or which table to use, right? So after you read through a scenario, you can ask yourself two questions in order to determine which formula or table to use. First question, is it a one-time payment or a series of payments? And that will help you determine whether or not you're looking for the value of $1 or the value of a series of payments. And then the second question is the question asking to calculate future or present value? And that one's pretty easy to find, right? Because the question itself in the scenario will ask either future or present value. So those are the two questions that, if you ask yourself those questions, should lead you to the appropriate formula or table for your practice cases for this week. One last thing I just want to mention here in terms of this unit, and I think I highlighted this at the beginning, but I want to reiterate, and that's that, effective sport practitioners understand the changing value of money over time and how it will impact the business decisions that they make. And I want you to keep that in mind as you're looking at the various practice cases over the next week, and keep thinking about how this information might impact the business decisions being made, whether it's a player signing a contract or a sport practitioner in a front office determining some kind of business deal. Consider the fact that the changing value of money over time certainly will impact the decisions they make. All right, that's all I have. Have a great week.